Greetings. Some of you in this room know this tagline from our biofuels project, the WSU-led Northwest Advanced Renewables Alliance. I'm warming up to whether or not it applies to mass timber. It might be a little too focused on our tall wood buildings, but I want to use it to emphasize our areas of focus in research, education, and outreach at WSU in looking at a complete supply chain. And the real title in your handout is a pilot supply chain for the Pacific Northwest. I'd like to recognize our delegation here this week and my mentors on all these projects and co-PIs on the research projects. We represent a few different entities at the university, a broader umbrella institute for sustainable design that can look at these big picture bioregional scale problems. The Composite Materials and Engineering Center, which is an accredited testing lab for wood products, a long history in wood products, wood plastics. And then the Integrated Design Lab, which I represent directly as director, which is more outward facing to connect directly to real projects with architects and engineers. And multiple federally sponsored projects are captured in this work. Specifically, I'd like to recognize a project we kicked off with the Forest Service last year, directly targeting these conceptual frameworks for pilot supply chains. In that, these projects do exist in our network. We have a strong Pacific Northwest network. We tend to have to sense border battles, especially between Oregon and Washington, but in reality, we work very closely together and work quite well together. And at WSU, this does extend beyond just our research. We have formal teaching mechanisms to bring together engineers and architects in studio models and architecture, bringing the engineers into that design mentality, but then also being able to tie that directly to sponsored research. And we just moved into our new building, the PACCAR Environmental Technology Building, where this work happens. So we are good at the conceptual, at the aesthetic, but also at the ability to take that design mentality across architecture, engineering, material science, and engineering, and jump scales. And that's what this talk is really about. So getting into supply chains, one of the glue that really pulls us together is the concept of vertical integration. And I have both a structural engineering and architecture background. So I recently visited Detroit, and my interest from practice was in adaptive reuse of post-industrial buildings and post-industrial sites. So I was heading north of Detroit, but I had time to see one building, and this is the building I pulled off the freeway in a kind of a rundown part of town, unfortunately. But this is Highland Park plant. This is a Ford plant from 1910, and this is significant slightly because of the architecture. It's an Albert Kahn building, but more importantly, it's significant to all of us for the transformation that it initiated from everything from manufacturing, from lean manufacturing to some will argue urban sprawl, and essentially our globalization of across many different areas of our lives. If you don't know, this was Henry Ford didn't necessarily innovate the assembly line. He innovated the vertical integration, and is quite literal in this building, where raw materials would come in the top floor, and they would assemble and stamp out the parts for the body and assemble the wheels. And by the time it got to that bottom floor, a Model T drove out the door. And that was actually short-lived, because then he very quickly realized, well, I could make that wheel across the street in a different building. And that led into the River Rouge plant, the idea of a manufacturing campus. And then very quickly that turned into, well, why can't I manufacture that part in Ohio or California or eventually Japan and China, which leads into our standardization of shipping containers and other things in the 1950s and 60s, which also coincided with the development of our interstate system. So all of these different developments came out of one building. these buildings are significant in that Ford model, and a few years later, Henry Ford went to Minneapolis and built a 10-story version of that, where now, by the time we got to that first floor, it was a showroom, and you actually walked in and saw your Model T there and then drove it out. In Seattle, for those of us in Pacific Northwest, we know this building on South Lake Union. And that gets me to where I learned timber engineering, and it was in this adaptive reuse, a seismic retrofit after the Nisqually earthquake in 2001. One of the best ways, I think, to learn timber engineering is to reverse engineer what we already have. So this is where I learned how the connections and the ability to take these heavy beams and columns, but then have to apply technology in our seismic retrofit. And that carries today in learning from these old buildings, how we are relearning and examining things we knew once, but now are applying new forms of technologies, and more importantly, tying that into this vertical integration, this prefabrication that we heard about in the session before this on the other side. I think the Europeans, especially the Australians, bring that perspective and are proving it, that it goes beyond just efficiencies across our wood supply chain, but it goes into looking at this holistically of tying the other types of systems and the systems integration. And this is our building under construction. I'd like to show it under construction. It is completed now, but this really celebrates the wood front, the entry to this. The rest of the brick building is concrete for purposes of the research labs, the wet labs in there. But this whole box in the back is our new large format testing bay, seminar room, and then that studio exists on this first floor. So as soon as you walk into this building, you understand this specialty and this priority in understanding wood projects, timber engineering. We have another example on campus, a simple shed roof pavilion with CLT. So where this leads is our ability to connect with our professional partners and industry partners and look and develop different typologies for office, commercial, and even parking, as we heard earlier from Springfield, and being able to look at the adaptive reuse that we need in the Pacific Northwest for seismic, and the role of mass timber, CLT perhaps, in tuning these buildings in a specific way that's different than we do with steel braces and concrete shear walls. In those partnerships, the development of an entry to the tall wood competition, we obviously heard about the Portland and the New York project, or we will today, but our entry was focused on the supply chain, bringing this diverse group of 18 partners together to imagine what is it going to take in our supply chain. And I want to propose something now and then circle back on at the end that a phrase with 4 P's in it, that this is about points and parameters and not necessarily plaques and petals. And let me come back to that. So in this supply chain, leveraging our work in biofuels, looking at wood utilization across the, I'm sorry, for an entire tree. The NARA project, the biofuel project, looked at those forest residuals in red here. What do you do with the branches, the tops, the needles, that biomass that might get left on the forest floor if there's not a market for it? What's appropriate to leave behind, of course, for soil health. But I want to make sure that we continue to tell this whole story in our projects, that the first and best use is the saw log, and that leads to our products such as mass timber, CLT, but we also need to complete the story. And so that something like this slash pile that especially on the east side, probably gets burned. In this work, we looked across where the markets are. So to fly an airplane, a jet on this to make a biofuel, we of course look where this goes, how we get it there to the major airports, SeaTac and Portland. In the same way, we can do that with the saw log. And so learning and taking those methods across that same area, now the markets become the urban areas, specifically Seattle and Portland. And this map shows with scaled dots in terms of population. It's very clear where these buildings, where this urban density is needed, especially with Seattle as our fastest growing city in the U.S. And so connecting that gray our forest cover, and on this map, the dark gray represents our public, specifically our federal lands. How do we connect the gray and the red? And that's what this presentation is about. Looking at the different scenarios. So going all the way to the market end first, looking at this band we talk about between 4 and 16 stories, this represents specifically in Seattle by story height on the vertical axis and by year up till present day, and then showing that band of 16 stories. This is by construction type, so the red dots are concrete if you can't see that, the blue dots are steel, and then the darker gray would be wood. And we see that, as we know, there's not a lot of construction in wood and office, but then we get to multifamily and we see that whole band, especially in Seattle and Portland, of those 5-story over 1 stick frame buildings. And then this gap that we talk about between 65 feet and 125 or 160 feet. So knowing that market, knowing where we're going, understanding in a city like Seattle where those exist, our South Lake Union, our zoning, our market pressures, where these types of developments would happen is obviously a critical piece on the market end of the supply chain. Looking at both, we've heard a lot about the code limitations, construction types, a great tour on Tuesday, and trying to understand all of the different construction types in those buildings, even if they were similar occupancies. But then crossing that, of course, with our very specific zoning characteristics, and in the state of Washington, having to go jurisdiction by jurisdiction to work with the building and fire officials. And so in that, at WSU, we get very specific in the research and development and the testing to go by species. What species are we talking about? We heard yesterday in Oregon, of course, is Doug fir, and you see this very dense red here representing the coastal forest, and but also knowing in our story that distinction between coastal Doug fir and inland Doug fir. And then also the hemlock species on the peninsula. And so going through actual testing for our species, both in terms of making and breaking, this is our new large format lab at WSU. But now getting into the transportation logistics and understanding how we connect those mills, where would we want to place these presses, the digital fabrication. And so breaking this down across the state of Washington into 4 different ecoregions that have very different characteristics in terms of climate, habitat, but also proximity to that main market of Seattle and then eventually Portland. So not only looking at the highway of the transportation of the final product, but also of the logging. So being able to reach out from those mills that either are underutilized or mothballed right now, and understanding their reach into all of the different forest types, so the land ownerships, and the different needs of those. And so using real mills, but using them in a comparative analysis for this logistics of getting this to South Lake Union, in this case, of how many miles of road and rail and crossing water, understanding through GIS network analysis the actual drive times based on the speed of that road, whether it's logging or dirt or arterial. So getting establishing these parameters that will be in these models. And so now as you propose these projects, you can be very specific about understanding that metadata that goes into our LCA and our other types of analysis. And so now adding some different colors to this map in terms of restoration needs. And so we see now in this map the reds and the oranges in terms of fuel reduction for wildfire, the blue dots, which are some of the beetle kill information. So looking out at that, especially on the inland side of the different needs that vary from the habitat restoration on the peninsula. So understanding that wildfire is a very important part of this story for us, very close to those of us that live in the inland Northwest. So specifically looking at the small watershed scale of understanding where that tree came from, what's the slope, being able to to actually capture that information in our panels, in our models. So now the vision. The vision is that we start with this integrated forest-to-building supply chain, and that, but in that we connect the resource side to the market side by leveraging the architecture, the engineering, and the construction technologies that Emily talked about in the previous presentation. Of course, the building information modeling, and how does that not only drive the fabrication models, which we hear a lot about in some of the presentations on the other side, but it also gets all the way down to that landscape level and how that was harvested and what the driving factors are. So the objectives in this, I would propose, do start with that forest management and health and the rural economic development that Dean Manis talked about yesterday. And then third, not in terms of priority, but maybe in terms of messaging, is that, of course, this is a sustainable option. And so I think, especially for our professional practice members in the room, often we start with that sustainability, and working for the Institute for Sustainable Design, of course, we speak that language, but treating it more like we treat gravity. Of course, we're doing that. The building's not going to fall down. It is going to be sustainable, and we know that the strength of the story for timber fits into that. So now, getting to the scenario modeling. Breaking down the process of making, in this case, CLT, step by step through the process, and being very open to challenging what we know. What we know right now is a model where we have a lumber that hits the market as a commodity and then goes to a manufacturer, often a glue laminator that knows how to press, knows resins, knows the types of processing. But in the Pacific Northwest, with our strengths in advanced manufacturing, let's open this up and look at different possibilities. So specifically focusing on two here, the steps of harvesting, milling, pressing, subtractive manufacturing, which is our CNC routing right now, that now would go straight to the job site as a mass customized panel, but now does not have the systems integration that we heard about from in the previous panel. So now, looking at a supply chain and that might bring some of this pressing perhaps to a mill, and asking and not dismissing that possibility, and then taking our Boeing-type mentality in the Pacific Northwest and saying, we are good at this. We can make things that fly. We can make buildings that are prefabricated. So just going through a few images of those steps that most of we're familiar with, the milling process, of course, but that the mills also need, and I'm showing an image here from Vaughan Brothers in Colville, the ability for the higher grade lamb stock, for the machine grading that's necessary for, if we're really taking this parametric approach to performance-based design, we want to understand the value of every lamb. Now, you can make an argument that that's not critical, that we can make a low-quality argument within the panel, but I'm proposing that with the capabilities, if we're leveraging the architecture, the engineering expertise, that we want to know. We want to know that the structural properties. We want to know the density, the moisture content, of course. We might want to know the aesthetic properties of every single knot on there. We have that ability. We might not use it, but we have that ability to think that way. So machine grading is one example of, and certain types of scanning and other modeling of the actual logs and the lamb stock is interesting. Of course, the technologies in pressing, showing some of the research partners up at SmartLam, but now taking that big leap into that advanced manufacturing. What if we have that Boeing-type thinking? And this is one of the research partners, Berg, that takes that type of approach in other areas outside of our building sector for now, but understand that ability of lean manufacturing and what it means to move big pieces through a factory of procurement of all these components and parts that Emily talked about. And so in addition to that, understand the advanced manufacturing, the digital manufacturing capabilities that is going to lead to additive manufacturing. We will be 3D printing these things. We already have European companies that are thinking that way of placing lamps in certain places and not placing it in others. And as we move forward, we're going to find other advanced 3D methods for wood products. So I leave you on this slide. Getting back to my what I submitted was points and parameters and not petals and plaques. And I'm taking a little bit of a shot at third-party certification of LEED and Living Building Challenge in that, and I mean that lightly because those are important market adoption mechanisms for us. But if we shift our thinking to this performance-based design, not only for buildings but for the entire supply chain, these are our points. And in our story of every building, let's make sure that we can grab one of those points in our model and tell that story. Let's start there. The petals and the plaques will come after. Thank you very much.